For this last addition and subtraction strategies video, we're going to talk about the US standard algorithm for addition and subtraction. Before we dig into that, let's just quickly determine what's the difference between a strategy and an algorithm. So strategies are number-based. It means that I'm going to pick certain strategies because the numbers lend themselves to thinking that way. The numbers make sense with the kinds of moves I'm going to take when I use that strategy. With algorithms, they're digit-based. So no matter what the numbers are, I'm going to use the digits in the number the same way and follow the same steps. Similarly, strategies have flexible options. So I might have 5 or 6 different strategies to choose from when I'm adding a number. Once I look at those numbers and decide which strategy the numbers are the best fit for, then I can think about how I want to apply that strategy. So different students might solve the same problem using the same strategy, but still have different steps in their problem-solving process. Whereas when I choose to use the US standard algorithm, everybody using that algorithm is going to solve the same way and take the same steps. So here's some strategies that we've spoken about on the last videos that you watched earlier in this topic. Take a minute, maybe pause the video and see if you can name what strategy is being used in each image. Go ahead and hit play when you're ready. So you might have noticed that strategy A, or image A here, is counting on. And they added 15 to get to 400, then 100 to get to 500, then 80, then 1. In strategy B and strategy C, I used making a friendly number, make 100 in this case. The difference between B and C is that I made 100 with different add-ins. So once I chose my strategy to make a friendly number, I had choices which number or which add-in I wanted to turn into that friendly number. D is also counting on, but it's specifically counting on by place value units. First, we started with the largest place value unit, then we worked our way to tens, and then we worked our way to ones, and you'll see at the end there was a little bit of a make 10 strategy applied there too. On this slide, A through E all show the US standard algorithm for addition. Now I say the US standard algorithm for addition because there are many algorithms that we can use to add. And the one that we tend to use regularly in the United States, we refer to as the US standard algorithm. Different countries and cultures have other algorithms that they use. So again, to go back to that first slide, algorithm means every person who solves it is going to follow the same steps in the same order. So pause the video here and think about how A, B, C, D, and E show the same steps happening in the same order, even though the representations we're using to show our thinking are different. So pause the video while you think about that and hit play when you're ready. So I hope you noticed that in all of these images, we started in the ones place. And when we add 5 ones to 6 ones, we got 11 ones. And 11 ones in all of these representations is composed of 1 10 and 1 1. Then we added the tens next. And when we added 8 tens plus 9 tens plus the 10 that we composed with our ones, we get 18 tens. 18 tens are made of 108 tens. Finally, we add our hundreds, and we're adding 3 hundreds plus 100 plus another 100 from our 18 tens to get 5 hundreds. So I hope you can see, despite these different representations, that the steps and the process and the thinking is exactly the same in every one. Take a moment here and reflect on how these different representations might help different students in your classroom access the US standard algorithm. So after you watch the rest of this video, you're going to fill out a note catcher and you're going to make a video of yourself talking through addition and subtraction standard algorithm for a problem to submit it as an assignment. So just be prepared to reflect on that question of how these different representations might help different students in your classroom make sense of the US standard algorithm for addition. All right, we're going to do the same thing with subtraction. So here are a whole bunch of different subtraction strategies that show different ways to approach the same subtraction problem. Pause the video while you see if you can name what strategy is used in each one of the images, and then we'll go over them when you're ready. So pause to think and hit play when you're ready. So A is take from 10, or in this case, take from 100. So we decided that 376 is almost 400, which is a friendly number, and decompose that 502 into its parts so we could subtract. In B and F, we are using constant difference. So B shows that if we subtract 3 from 502 and subtract 3 from 376, it makes an easier problem where we can actually use an algorithm approach to subtraction, but we don't have to do any regrouping because we use the strategy of constant difference. F on the bottom there shows on a number line why that strategy works for this problem and why constant difference works as a strategy. When you look at C, we counted back to subtract. D, we counted on to subtract. So we talked about count on and count back in a video. It's very interesting to me that in D, it only took 2 steps to count on, as opposed to C, where it took us 4 steps to count back. E, you'll also see a student that counted on, only in this example, counting on took 4 steps. So depending on my number fluency and my fact fluency, my number sense, counting on and counting back might be more or less efficient. If you have any questions about some of these strategies, you might want to go back and rewatch those videos. Let's look at the algorithm. So I don't have quite as many representations here, but we can have the same conversation. Again, the US standard algorithm for subtraction is a prescribed procedural set of steps that when I use the US standard algorithm, I'm always going to go in the same order, and every student that uses this strategy to solve is going to do it the same way. Or it's probably not going to work because they made a mistake. So again, pause the video here and think about the different representations and how all 3 representations show the same steps in the same order, even though the representation showing the thinking is different. Go ahead and hit play when you're ready. In these 3 representations, you can see that we started in the ones place. We didn't have enough ones, so we needed to get some more ones. So we went over to the tens place, but there's a 0 in the tens place. So we need to go over to the hundreds. When we take one of our hundreds and rename it as 10 tens, that leaves us with 4 hundreds. Then we still need to get more ones. So we're going to take one of those 10 tens and rename it as 10 ones to give us 12 ones instead of 2 ones. And when we do that, instead of having 10 tens, now we have 9 tens. So by the time we're done with all the renaming, we have taken the quantity 5 hundreds and 2 ones and renamed it using different place value units. After we moved stuff around, we have 4 hundreds, 9 tens, and 12 ones, which adds up to 502. We just renamed or decomposed some of those units so that we have the quantities in the places where we need it to subtract. Once we were ready to subtract, 12 ones minus 6 ones is 6 ones, 9 tens minus 7 tens is 2 tens, and 4 hundreds minus 3 hundreds is 100. So again, after watching this video, you're going to take a moment to reflect on how different representations might help your students access and be more successful as they're learning that US standard algorithm. And you're going to have the opportunity to create a video of yourself using the place value language that you've heard me use, talking through the process of using the US standard algorithm for addition and subtraction. Really being aware of keeping that concept and all of that place value language connected with the numbers so that using the standard algorithm doesn't feel like a procedure that we go through where we lose all context of what the numbers mean and the values of the different digits.